Now you're probably asking yourself the burning question, why are Laplace transforms so important? Why do we care about them? And it's all based on the following miracle. Namely, if you take the Laplace transform of the derivative of f to the Laplace transform of f prime of t, it gives you s times the Laplace transform of f minus the value of f at 0. You may say, this is when it's important. What does that even mean? Well, what it means is the following. It tells you that the Laplace transform, what it does, it turns differentiation, which in practice is very hard, into multiplication, because we're just multiplying L of f by s into multiplication. Easy. And in particular, what it will do, it will turn differential equations again, which are hard, into algebra equations. Which is much easier to solve. I mean, remember how much easier algebra 2 was compared to calculus. So the Laplace transform will turn differential equations land into algebra 2 land. And we'll see this will be extremely useful. Now, you may wonder, why is this true? So it's just based on an integration by parts, because the Laplace transform of f prime of t, by definition, it's the integral from 0 to infinity of f prime of t, e of minus st dt. So think of f prime as you du. So if you integrate by parts, du becomes u. So f of t times e of minus st from t equals 0 to t equals infinity minus integral from 0 to infinity of f of t. So u dv. So here differentiate with respect to t to get minus s e of minus st dt. And then remember, we always assume the terms at infinity are 0. So you have 0 minus f of 0, e of minus s times 0, and then minus minus becomes plus. So minus minus becomes plus. And also this minus s, because it doesn't depend on t, just comes out of the integral. So in the end, we have plus s, integral from 0 to infinity, f of t, e of minus st dt. But then in the end, once this has settled, this becomes minus f of 0 plus s times the Laplace transform of f of t. So this becomes s L of f of t minus f of 0, which is precisely what we want. S L of f of t minus f of 0. And once again, that's very important because it transforms differential equations into algebra equations. And we'll see very important applications of this in the next lecture. But before we end this, we did this for first derivatives. The same thing holds for second derivatives. But here it's much easier. We don't even need to integrate by parts. We can just use the formula above, because the second derivative of f is the derivative of the first derivative. So f prime prime, and then you can just use a formula above that says is S L of f prime of t minus f prime of 0. And once again, you can use a formula again. So it's S times S L of f of t minus f of 0 minus f prime of 0. And then we get S squared L of f of t minus S f of 0 minus f prime of 0. So as a consequence, we then get the Laplace transform of the second derivative also turns into an algebra equation. In this case, into something quadratic. Minus SF of 0 minus f prime of 0. And no, you don't need to memorize those formulas. They will be given to you, although I may ask you to rederive it in the same way as I did here. And in the next lecture, we will see how to use those miracles to solve ODEs.